and
are
B,
red-eyed, so they're equal.
right?
And
You
then BC,
yes. You mean this one is equals
yes.
to this one, right? And then we are also we also know that these two are also equal. Uh, since B it's on the same line with M, right? That means it's at the middle. Okay, so our did we okay we were given alpha. So here, since
Wait,
these two lines,
what reason can, sorry, what reason can we use for BA being equal to BC?
uh, we can say that it is a kite, right? Because yeah, if we can see M and B, they are on the same line, right? And we were told that M is the center of that cylindrical shape. Yes. So you can say BC is equals to AB. Your reasoning it's a kite, right? Right.
Okay.
So since they said it is a tangent, right? So that means this is a radius, right? And a tangent. And we know what does a radius and the tangent tells us. It tells us we are having a 90-degree angle like this, right? And
Mm.
we also know that this is alpha and this one is also alpha. It's also alpha, right? Okay, we were not given theta. Um, what I can say is that if we can draw a line here, we are going to be having a 90-degree here. So we can just find this side and use maybe here it's going to be 90 minus alpha, and yeah, if we can find one, only just one side, and then we can find the other one, right? So we can calculate for AC. So AC is equals to D, the root of 2 plus 2 cos 2 alpha, and our D, we are given D, right? They said is 10,3 meters. 2 plus 2 cos 2, and then our alpha was 54 degrees, and then you are going to punch this on your calculator. It's our meters, and then we are simply going to divide this number by 2, right? And then if you divide it by 2, let me put L here for Lelo. Okay, let me put L for Lelo. So okay, you can say LC is equals to AC divided by 2, right? You're going to take that answer, you divide it by 2, you're going to get 6,054,188,099, and then you are simply going to use your trigonometric ratios, right? Since you are having this angle, this smaller angle here, you are just going to say adjacent over hypotenuse. We want MC, so we are going to say um, what is our angle C? We are going to say 90 degrees minus alpha, and now we know alpha is equals to 54 degrees, right? It's 36, right?
36.
Yes, you're
Yeah.
going to get 36. Then you're going to say on that smaller triangle at the top there, going to say adjacent over hypotenuse, right? So cos C is equals to LC over MC. And then
Mm.
MC cos C is equals to, actually we are looking for, okay, let's get on LC, and then we divide by cos C both sides. So our LC, right, is 6,54188,099 divided by cos 36.
Did can you go to the top? We didn't square. Did we square that?
Ah, damn. Yes, we forgot. We forgot to square. I was like, how come? It can't be.
Exactly.
Can't be. Let me see. Let me try to put a square. Ah, okay. Ah. You find the very simple. Wow. Yeah, I'm tired. I'm tired now. I'm tired.
No, I up to this one, really. We are done.
Tired. Okay, so our age is. Yo, I was stressed. I don't wanna lie. Yeah. After putting the square, we are getting the very same answer. You see now,
Mm-hmm.
I'm glad. Yo, like I was so stressed. I was like, yeah, I have to start
Yeah.
again.
Never.
It can't
Okay,
be.
can you just for me, can you just zoom out and then can I just digest what we just said?
Yeah, no, hi Ilelo. I don't know how to answer you. Okay, okay. Let's start from the beginning. Ne? Ask me,
Okay, yeah.
ask me the very first question, and then I'll answer, and then yeah.
Okay,
Mm.
sharp. Why did you start with the bisector?
Okay.
I mean the yeah, no, the diagonal. The
The
diagonal.
diagonals, right? So I wanted,
Mm.
like, my main mission was to find MC, right? That was my main mission. So that's why I calculated AC,
Why?
because
Yes, yes, yes.
I am given a formula that I can just calculate AC, right? So I used it.
Yeah, yeah, you now you're on the right track of answering. You said your main mission was to calculate MC. Why was that your main mission?
Because
How does calculating MC help you?
um, it's our radius actually of this cylindrical uh, seal, yeah, siloids.
Oh,
Yes, it's the radius.
I get it.
Eh,
It's the radius. Hey, okay. No, sharp. Okay. The radius. Emenko was is okay.
eh.
And then okay, go down. Just 2 cos C
Go
equals to
down.
LC. Go down. Okay, okay. Sharp. Your main goal was calculate the radius. I understand, ne? And then MC was going to you calculating. I mean, not MC. LC. Why did you now calculate LC?
Yes, LC. I calculated LC because if I can get LC right, that means I'm having a right
Mm.
angle triangle. So I can use a simple trigonometric ratio. You see.
Oh, half LC MC sine. Oh, okay.
Yes, I'm going to say adjacent over hypotenuse because I want to calculate MC, but I am having LC right now. It's the same as having just a
Mm.
triangle like this. So this is LC, this is M, and then we are having this angle, right? which is 36. Then we are having our LC. So I was like adjacent over hypotenuse. The reason why I didn't use the whole like the like AC, I mean, it's because I wanted to work with the triangle, with the right angle triangle actually, so that I can use a simple trigonometric ratio,
Mm.
uh, which is cos C. Isn't it adjacent over
Ah, Shem, I
hypotenuse?
get you.
Yeah,
I get you 100%.
100%.
You see now,
Mm.
I'm with you 100%. Abona. Now I Shem, I can even go to sleep. Now I yeah no, 100%.
Uh-huh.
No, now I get it. Yeah no, I yeah no now. Yes, okay. Our main target was MC because